Imagine a thriving civilization, identical to ours, orbiting a stable yellow dwarf star. They have built sprawling cities, split the atom, and just begun to map their local planetary system. Then, in a fraction of a second, their entire atmosphere is stripped away. The oceans flashboil into steam. The crust of the planet turns into an unrecognizable sea of molten glass. There is zero warning. The beam of gamma radiation, fired from the poles of a collapsing star 3,000 light-years away, travels exactly at the speed of light. Because the agent of destruction moves at the exact same velocity as the visual information of its arrival, you cannot see it coming. By the time the sky lights up with blinding, impossible energy, the biosphere is already ash. This is not a hypothetical horror scenario engineered for entertainment. It is a standard, routine operation of astrophysics. We exist in an environment that is, fundamentally, a machine perfectly calibrated for mass sterilization. For over 60 years, we have aimed our most sensitive instruments outward, tuning our antennas across the cosmic radio dial, based on the sheer mathematics of the galaxy. Hundreds of billions of stars, surrounded by hundreds of billions of planets, existing for nearly 14 billion years. The sky should be deafeningly loud. It should be a crowded, vibrant network of ancient empires, megastructures, and interstellar traffic. Instead, we are met with absolute, unbroken silence. We casually refer to this anomaly as the Fermi Paradox, but that term is a dangerous comfort. A paradox implies a mere puzzle, a temporary misunderstanding of the data waiting to be unraveled by a clever mind. But the silence we are hearing is not a puzzle. It is an autopsy report. We are wandering blindly through a cosmic graveyard, deeply optimistic, completely unaware of the mechanism that slaughtered everyone else. We have romanticized the cosmos as a fertile cradle, a vast ocean waiting for life to inevitably set sail and conquer the dark. But the raw, unfeeling mechanics of thermodynamics and stellar evolution tell a brutally different story. It is a story of violent cosmic resets, invisible radiation sweeps, and inevitable, catastrophic dead ends. The mathematics suggest that somewhere between the first accidental spark of single-celled biology and the rise of a civilization capable of manipulating the stars, there is a wall, an insurmountable barrier, a great, invisible filter that almost nothing survives. And the most terrifying question in the history of human existence is not whether this lethal mechanism exists. The evidence of its existence is the profoundly empty sky above us. The true horror lies in a different question. Are we the one statistical anomaly that has already managed to slip past the filter? Or is the filter still waiting for us in the near future? If you are willing to abandon the comforting illusions of science fiction, if you seek the unvarnished truth hidden within the dark and violent mechanics of reality, subscribe and join us on this journey. We are going to look directly into the abyss, but be warned, the universe does not care if we are here. Humanity has spent the vast majority of its existence under a comforting delusion of central importance. For thousands of years, our ancestors looked up and saw a bespoke canopy. The stars were fixed on crystalline spheres, rotating politely and predictably around the Earth. We were the undisputed focal point of creation, the primary concern of the cosmos. Then, a few centuries ago, a handful of astronomers, armed with crude glass lenses, shattered that celestial sphere forever. We were violently demoted by our own observations. The Earth was just a rock. The Sun was just an average, middle-aged star. The Milky Way was just one of an unfathomable number of galaxies drifting through a cold void. We called this profound shift in perspective the Copernican principle, or the principle of mediocrity. It is the fundamental, underlying assumption of modern astronomy that there is absolutely nothing special about our time or our physical place in the cosmos. Ironically, this ultimate demotion gave birth to the greatest wave of cosmic optimism in the history of science. If we are not special, then the dirt beneath our feet is ordinary. The carbon in our blood is common. Therefore, the spark of life must be painfully ordinary to we. If nature managed to conjure life out of primordial soup on this random rock, it must be doing the exact same thing on countless other rocks across the galaxy. In the middle of the 20th century, specifically in 1960, this optimism was codified into a mathematical framework. A young astronomer named Frank Drake organized a meeting in West Virginia and wrote a sequence of variables on a chalkboard. It was not meant to be a rigid physical law, but rather a way to stimulate conversation about the search for extraterrestrial intelligence. Yet, it quickly became the holy grail of our cosmic expectations. The logic of the Drake equation is intoxicatingly simple to follow. You take the average rate of star formation in our galaxy. You multiply that by the fraction of those stars that have planetary systems. You multiply that again by the average number of planets per system that reside in the habitable zone, where liquid water could theoretically exist. Then, you factor in the fraction of those planets where life actually emerges, the fraction where that simple life evolves into complex intelligence, and the fraction of those intelligent species that develop technology capable of broadcasting their existence to the void. Finally, you multiply it all by the length of time such civilizations release detectable, artificial signals into space. When you run these numbers, even with incredibly conservative estimates for each variable, the result is staggering. The mathematics suggests there should be anywhere from thousands to tens of millions of active, communicative civilizations in the Milky Way alone. We looked at the numbers, we looked at the sheer volume of stars, and we felt a profound sense of relief. We were mathematically guaranteed company. 10 years prior to Drake's formulation, during a casual lunch at the Los Alamos National Laboratory in 1950, the brilliant physicist Enrico Fermi was discussing a recent wave of UFO reports with his colleagues. Knowing the vast age of the universe and the immense number of stars, Fermi reportedly performed some quick mental calculations and asked a deceptively simple question that would haunt astrophysics for a century. He asked, "Where is everybody?" Our intuition tells us that the universe is a vast, calm ocean just waiting to be explored. But this intuition is a lie, born from a severe biological limitation. Our brains evolved on the plains of Africa to track predators, find water, and survive until the next sunrise. Our neurological perception of time is rigidly calibrated to a fleeting window of perhaps 80 or 90 trips around the sun. When we walk outside on a crisp, cloudless night and look up, the universe appears static. It looks like a painting, a peaceful, silent tapestry of ancient light. But you are not looking at a painting. You are looking at a frozen, high-speed photograph of an ongoing, hyper-violent explosion. Space is not an empty void waiting to be filled with utopian societies. It is a highly active, incredibly lethal environment governed by the unforgiving laws of thermodynamics. Our intuition whispers that a planet orbiting in the Goldilocks zone is a safe harbor, a tranquil island in a rough sea. But that is a profound misunderstanding of how solar systems actually operate over deep time. Let us completely dismantle the illusion of planetary stability. To build a world like ours, you do not gently assemble matter. You smash it together in a chaotic, hellish accretion disk. For the first few 100 million years of a solar system's life, there is no peace. It is a demolition derby of protoplanets, comets, and rogue planetesimals slamming into one another at tens of thousands of kilometers per hour. The early Earth was a molten hellscape, a churning sea of magma endlessly bombarded by leftover debris. The energy released by these kinetic impacts would boil oceans and melt the very crust. But let us assume a planet survives the initial bombardment. Let us say it cools down, forms a solid silicate crust, and accumulates oceans of liquid water. Intuition tells us the hard part is over, but the clock of the universe operates on millions and billions of years, and over these vast stretches of deep time, the environment is relentlessly trying to kill whatever fragile order arises. We think of our Earth as a standard template for life, but planetary geologists increasingly subscribe to the rare Earth hypothesis. This is the realization that a staggering number of highly improbable coincidences had to occur just to keep this planet stable long enough for you to be born. For instance, we have a massive gas giant, Jupiter, orbiting perfectly in the outer solar system. Jupiter acts as a gravitational vacuum cleaner, sweeping up devastating comets and asteroids that would otherwise constantly sterilize the inner planets. Furthermore, Earth was struck by a Mars-sized object early in its history, a cataclysm that resulted in the formation of our unusually large moon. Without the gravitational anchor of that massive moon, Earth's axis would wobble chaotically over millions of years, causing wild extreme shifts in climate that would repeatedly freeze and fry the surface, preventing complex life from ever gaining a foothold. And then there is the star itself. Stars are not perfect, steady burning lamps. They are turbulent, magnetic fusion reactors. They frequently throw off massive solar flares and coronal mass ejections. If a planet does not have a powerful, rapidly spinning core of liquid iron generating a strong magnetic field, these stellar storms will gradually strip the planet of its protective atmosphere, blowing it out into deep space. A planet that loses its atmosphere inevitably loses its oceans, turning a potential cradle of life into a desiccated, irradiated wasteland like Mars. Consider the sheer mathematical improbability required to maintain a stable climate for the 4 billion years necessary for single-celled organisms to evolve into something capable of building a radio telescope. The planetary thermostat must remain perfectly balanced on a razor's edge. If the planet traps just a fraction too much heat, the oceans begin to boil, the rocks lock up carbon dioxide, and you trigger a runaway greenhouse effect. You end up with a world like Venus, where the atmospheric pressure crushes metal and surface temperatures can melt lead. If the planet loses too much heat, the oceans freeze solid all the way to the equator, creating a snowball world where life is suffocated beneath kilometers of solid ice. Our intuition fails us because we are living in a temporary, bizarrely quiet, interglacial period on a planet that has undergone at least 5 major mass extinctions. We look at our green forests and blue oceans and assume this is the default state of the cosmos. We conveniently forget that over 99% of all species that have ever existed on this planet are dead. The Earth has actively tried to wipe out its own biosphere through volcanic winters, toxic atmospheric shifts, and oceanic anoxia. Even biology itself is a lethal weapon. Around 2.4 billion years ago, a new type of bacteria evolved the ability to photosynthesize, pumping massive amounts of oxygen into the atmosphere. To the anaerobic life forms that dominated the planet at the time, oxygen was a highly reactive, deadly poison. This event, known as the Great Oxygenation Event, was a global genocide perpetrated by biology. It was one of the first great filters life on Earth had to pass through. When we start to comprehend the true violence of deep time, the Drake equation begins to look less like a promise and more like a deeply naive wish. The transition from simple, single-celled chemistry to a complex, multicellular organism is not a guaranteed escalator ride driven by the mere passage of time. It is a thermodynamic miracle. It is a brutal, uphill battle against the fundamental nature of reality. The universe strongly favors entropy. It favors chaos, disorder, and the breakdown of complex structures. Life is a bizarre anomaly. It is a localized, temporary rebellion against the second law of thermodynamics. It requires a continuous, uninterrupted flow of energy and a profoundly stable environment just to persist, let alone evolve. Let us look inward for a moment at the very concept of biological intelligence. Our intuition tells us that high intelligence is the ultimate pinnacle of evolution, the inevitable crown jewel of natural selection. We assume that if a species simply survives long enough, it will inevitably become smarter, figure out how to build tools, and eventually look to the stars. But the fossil record of our own planet tells a much colder story. Dinosaurs ruled the Earth for over 160 million years. They were incredibly successful, perfectly adapted biological machines. Yet, in all that vast ocean of time, they never forged a single metallic alloy. They never built a radio tower. They were unceremoniously wiped out by a random piece of rock falling from the sky, entirely unaware of the universe beyond their immediate atmosphere. Evolution does not care about exploring the cosmos. Evolution is a blind, unthinking mechanism driven solely by short-term survival and reproduction. Intelligence, especially the kind of energy-hungry, hyperanalytical intelligence that humans possess, is an extraordinarily expensive biological trait. The human brain consumes roughly 20% of the body's energy, while making up only about 2% of its weight. In the brutal, unforgiving economy of nature, such an expensive, vulnerable organ is a massive liability. Unless it provides an immediate, overwhelming survival advantage to overcome that energy deficit, it is quickly selected against. This forces us to consider a chilling possibility. Perhaps the emergence of technological intelligence is not the natural endgame of life. Perhaps it is an evolutionary freak accident, a bizarre, highly unstable mutation that is almost never replicated anywhere else. If you were to rewind the clock of Earth by 4 billion years and let it run again, there is absolutely no guarantee that humans, or anything remotely like us, would ever appear. The forests might be full of complex animals, the oceans teeming with efficient predators, but the night sky would remain entirely unobserved by any mind capable of comprehending it. And even if this freak accident happens, even if an intelligent species manages to forge tools and build a global society, they suddenly face a completely new set of self-inflicted existential threats. We look at human history as a straight, unbroken line of continuous progress, from the discovery of fire to the splitting of the atom. We implicitly assume this trajectory is infinitely sustainable. But the physics of complex systems dictates otherwise. A civilization that aggressively scales up its energy consumption inevitably increases its internal entropy. It becomes highly sensitive to disruption. We have constructed a society entirely dependent on fragile, interconnected systems. A single, powerful solar storm could fry the global electrical grid tomorrow, sending a high-tech society back to the 19th century in a matter of hours. And the silence we hear from the stars might not be the result of a single, dramatic, cosmic event. It might simply be the sound of millions of independent civilizations reaching the exact same technological bottleneck and failing to survive their own ingenuity. To truly comprehend the terrifying weight of this silence, we must first confront the physical scale of the arena. Our minds are poorly equipped to understand the true dimensions of the galaxy we inhabit. When you stand outside on a clear night, far from the light pollution of our cities, you might see a few thousand stars scattered across the black canvas. It feels incredibly vast. It feels like you are witnessing the entirety of creation. But that view is a deceptive, microscopic illusion. Almost every single star you can see with the naked eye is located within a tiny, immediate bubble surrounding our solar system. You are not looking at the Milky Way. You are merely looking out of the front window of your own house, staring at the porch lights of your immediate neighbors. The Milky Way galaxy is a sprawling, spiral metropolis of gas, dust, and dark matter, measuring roughly 100,000 light-years across. To understand that number, you must abandon miles and kilometers. A light-year is the distance that light, the fastest physical phenomenon in the universe, travels in 1 Earth year. Light moves at 186,000 miles per second. At that speed, you could circle the equator of the Earth 7.5 times in a single second. It takes light from our sun about 8 minutes to reach the Earth. It takes that same light over 4 years to reach the closest neighboring star system, Alpha Centauri. But to cross the entire disk of the Milky Way, from one edge to the exact opposite side, traveling at that incomprehensible, universe-breaking speed, it would take 100,000 years. Within this unimaginable expanse, modern astrophysics estimates there are somewhere between 100 billion and 400 billion individual stars. If you were to count one star every second, without ever stopping to sleep or eat, it would take you over 3,000 years just to count to 100 billion. And the Milky Way is just one profoundly average galaxy among an estimated 2 trillion other galaxies in the observable universe. The raw volume of physical space is so staggering that it crushes our intuitive sense of probability. The numbers are so large that even the most infinitesimally rare events should statistically be happening millions of times. For decades, skeptics of extraterrestrial life possessed a valid counter-argument. They argued that while there are billions of stars, perhaps planets themselves are incredibly rare. Perhaps the process of a protoplanetary disk condensing into solid, rocky spheres was a freak occurrence unique to our own sun. That was a comforting thought. It provided a neat, logical explanation for our apparent isolation. But in the year 2009, humanity launched a piece of machinery that forever annihilated that excuse. We launched the Kepler Space Telescope. Kepler was not designed to take beautiful, sweeping photographs of colorful nebulas. It was a highly specialized, hyper-precise statistical instrument. Its mission was to stare continuously, without blinking, at a single, fixed patch of the sky containing about 150,000 stars. It was looking for shadows. Kepler utilized a method known as transit photometry. If a planetary system is perfectly aligned with our line of sight, a planet orbiting its host star will periodically pass directly in front of it. blocking a microscopic fraction of the star's light. Imagine placing a massive, blinding searchlight in the city of New York. Now, imagine standing in the city of Los Angeles, thousands of miles away, and trying to detect the momentary, microscopic dimming of that searchlight when a single moth flies across the glass. That is the level of agonizing mechanical precision required for transit photometry. Kepler watched these stars for years, measuring variations in brightness down to fractions of a percent. And the results of this silent, patient observation fundamentally rewrote our understanding of the universe. Kepler did not just find a few planets, it found thousands. It proved, definitively, that planets are not rare anomalies. They are a fundamental consequence of stellar formation. The mathematics derived from Kepler's dataset indicate that, on average, there is at least one planet for every single star in the night sky. But Kepler went further. It allowed us to calculate how many of those planets sit in the so-called habitable zone, the narrow orbital band around a star where the temperature is just right for liquid water to pool on the surface, not too close, where the oceans would boil away, not too far, where everything freezes solid. Just based on the data from our own local neighborhood, astronomers now estimate there are between 10 billion and 40 billion Earth-sized, potentially rocky planets orbiting in the habitable zones of sun-like stars and red dwarfs within the Milky Way alone. 40 billion worlds, 40 billion massive, ancient spheres of rock, bathed in the warmth of their own suns, drifting through the vacuum. If even 0.1% of those planets had the right chemical soup to spark single-celled biology, that still leaves 40 million planets actively harboring life in our galaxy. This brings us to the most crushing variable of all, the variable of deep time. The human mind naturally assumes that the current state of the universe is how it has always been. We view the cosmos through the incredibly narrow lens of our own brief existence. Our species has only utilized radio technology for roughly a century. 100 years is nothing. It is a rounding error. It is a fraction of a millisecond in the context of cosmic time. The universe is approximately 13.8 billion years old. Our own solar system, the Sun, the Earth, and all the planets, formed roughly 4.5 billion years ago. This means that there is a terrifying gap of over 9 billion years between the birth of the universe and the formation of the dirt you are standing on. 9 billion years of stars igniting, burning through their nuclear fuel, exploding in massive supernovas, and seeding the interstellar medium with the heavy elements required to build planets and carbon-based biology. Entire solar systems formed, stabilized, and existed for billions of years before our sun was even a cloud of formless gas. There are rocky planets out there that are billions of years older than the Earth. If life takes roughly 4 billion years to evolve from single cells to a spacefaring civilization, as it did here, then there could be civilizations out there that achieved our current level of technology millions or even billions of years ago. Try to visualize the technological progression of humanity over just the last 1,000 years. Think of the leap from wooden carts and plague doctors to splitting the atom, landing rovers on Mars, and instantly transmitting high-definition video across the globe. All of that happened in 1,000 years. Now, imagine a civilization that has had 1 million years of continuous, uninterrupted technological advancement. Or 100 million years, the technology they would possess would not just be advanced to our eyes. It would be indistinguishable from fundamental magic. It would be capable of engineering reality itself. But surely, you might argue, Space is too vast to traverse. Even a highly advanced civilization could never cross the impossible voids between the stars, because the speed of light is the absolute speed limit of the universe. This is a common misconception that completely ignores the relentless, grinding power of exponential mathematics. You do not need faster-than-light travel to conquer the Milky Way. You only need time and a concept known as the von Neumann probe. In the middle of the 20th century, the brilliant mathematician John von Neumann theorized the concept of a self-replicating spacecraft. Imagine a highly advanced, automated robotic factory, heavily shielded against radiation, propelled by something as simple as nuclear fusion or a solar sail. You program this probe with a single, overarching directive: travel to the nearest star system. Upon arrival, the probe does not look for biological life. It ignores habitable planets entirely. Instead, it lands on a dead, airless moon or a large asteroid. It deploys mining equipment. It strips the rock of iron, titanium, silicon, and precious metals. It sets up solar arrays to harvest the energy of the local star. Then, using those raw materials and energy, the automated factory builds an exact, fully functional replica of itself. And then it builds a second one. Now, you have two probes. Both probes refuel, launch back into deep space, and travel to two new, unexplored star systems. They land, they mine, and they each build two more copies. Now you have 4, then 8, then 16, 32, 64, 128. This is the terror of exponential growth. The math dictates that even if these probes travel at a miserably slow pace, perhaps just 5 or 10% of the speed of light, and even if they take 1,000 years at each stop to mine and replicate, the resulting swarm would completely wash over the entire Milky Way galaxy in a remarkably short amount of time. Estimates suggest that a single, original von Neumann probe could spawn enough generations to visit every single star system in the galaxy in roughly 2 to 4 million years. For a million years feels like an eternity to a human. But in the grand calendar of the cosmos, for a million years is absolutely nothing. It is a brief, fleeting moment. Remember, there are planets out there with a head start of billions of years. Therefore, if the universe is truly a fertile ground for intelligence, the math presents us with a brutally clear, inescapable conclusion. If just one civilization, anywhere in the history of the galaxy, ever decided to build a self-replicating probe, the entire galaxy should be swarming with them right now. Every dead moon in our solar system should be mined. The asteroid belt should be crawling with automated refineries. We should look up through our telescopes and see the unmistakable geometric silhouettes of alien megastructures blocking the light of distant stars. We should see Dyson spheres, massive arrays of solar collectors entirely encasing host stars to harvest their total energy output, causing those stars to mysteriously dim and vanish from the visible spectrum while emitting massive amounts of waste heat in the infrared. The galaxy should look entirely artificial. It should resemble a heavily industrialized city, but we look out and we see nature. We see raw, unorganized, wild physics. We see chaotic clouds of hydrogen gas. We see stars burning and dying naturally. We see exactly what we would expect to see if we were completely and utterly alone in a dead wilderness. And it is not for a lack of trying. We have not just been looking with our eyes and our optical lenses. We have been actively, desperately listening to the void for decades. Since the middle of the 20th century, humanity has constructed massive, delicate ears pointing toward the heavens. We built the Arecibo Observatory, a massive dish carved into the jungle of Puerto Rico, capable of detecting the faintest whispers of electromagnetic radiation. We built the Very Large Array in the deserts of New Mexico, dozens of massive antennas operating in perfect unison to scan the deep sky. Radio waves are the perfect medium for interstellar communication. They travel at the speed of light. They easily cut through the thick clouds of interstellar dust that block visible light, and they require relatively little energy to produce. If a civilization is operating heavy machinery, managing global air traffic, or transmitting entertainment, those artificial radio waves should leak out into space, rippling outward in an ever-expanding sphere of noise. Our own sphere of radio noise has already washed over thousands of nearby star systems. Radio astronomers do not just listen randomly, they search with intense, logical precision. They tune their massive receivers to a very specific, quiet band of the electromagnetic spectrum known as the waterhole. This is the frequency space between the emission lines of hydrogen, the most abundant element in the universe, and the hydroxyl radical. Together, they form the chemical components of water. This specific radio frequency is remarkably free from the loud, chaotic background noise of natural cosmic radiation. It is the quietest channel on the galactic radio dial. Any intelligent species, anywhere in the universe, understanding basic radio astronomy would mathematically deduce that this exact frequency is the universal gathering place. It is the logical frequency to broadcast a beacon. To hear these potential signals, we push our engineering to the absolute limit. We cool the receivers of our radio telescopes with liquid helium, bringing their physical temperature down to just a fraction of a degree above absolute zero. We do this to stop the physical atoms in the copper wiring from vibrating, because even the microscopic heat generated by our own equipment could create enough thermal static to drown out a faint alien whisper traveling from thousands of light years away. We stare at the center of the galaxy, where the density of stars is millions of times higher. We stare at perfectly stable, ancient star clusters. We listen for a pulse, a mathematically structured sequence, a prime number sequence, a repeating radar sweep, anything that defies the random chaos of a dead universe. And what do we hear? We hear the loud, unorganized roar of quasars. We hear the rhythmic, mindless ticking of pulsars, dead neutron stars, spinning wildly out of control. We hear the faint, ambient hiss of the cosmic microwave background, the lingering echo of the Big Bang itself. We hear the chaotic, deafening noise of natural physics, but from the billions of worlds we know exist, from the vast stretches of ancient time where empires should have risen and spread, we hear absolute, terrifying silence. This is the true scale of the mystery. The paradox is not merely an interesting philosophical thought experiment. It is a massive, glaring contradiction between the mathematical probability of our own existence and the harsh, observable reality of our instruments. The ingredients for life are everywhere. The time available for evolution is practically infinite. The mechanisms for galactic expansion are physically possible and entirely achievable. The stage is set perfectly. The theater is massive. The lights are on, and the props are scattered everywhere. But the actors are completely missing. We are forced, against our will, to abandon the idea that the universe is a welcoming place. We are forced to realize that the silence is not a coincidence. It is an active, physical symptom. Something is wrong. The math works, the physics work, the planets are there, and yet nothing survives long enough to make a sound. There is a barrier, a violent, unseen mechanism operating in the dark. The great filter is not a myth. It is a mathematical necessity required to explain the empty sky. The only question left to answer is the exact nature of this physical wall, and whether we are looking at it in our rearview mirror, or if we are currently accelerating blindly toward it in the dark. In the late 1990s, an economist and futurist named Robin Hanson looked at the terrifying contradiction between the math of the universe and the silence of our telescopes. He realized that if the cosmos is a factory perfectly designed to produce life, and yet we see absolutely no evidence of it, there must be a flaw in our fundamental assumptions about how life progresses. There must be an evolutionary or physical wall that almost nothing can climb over. He called this concept the Great Filter. The Great Filter is not a single, specific event. It is a terrifying sequence of statistical bottlenecks. It posits that between the birth of a sterile, rocky planet and the rise of a galaxy-spanning civilization, there is at least one evolutionary leap or physical trial that is so overwhelmingly difficult, so mathematically improbable, that practically no one survives it. It acts as a universal sieve, catching and destroying millions of promising biospheres, leaving behind only the dead, silent rocks we see in our telescopes. The most urgent mystery of the Great Filter is its location in our own timeline. Is the impenetrable wall firmly behind us, buried deep in our evolutionary past, or is it waiting for us, looming in our immediate future, a physical inevitability that we are blindly accelerating toward? Let us first examine the desperate hope that the filter is already behind us. We look at the history of our own planet, and we find a biological anomaly so absurd that it defies all thermodynamic logic. For the first 2 billion years of life on Earth, biology was trapped. The oceans were filled with simple, single-celled organisms, primarily bacteria and archaea. They were remarkably successful at merely existing, but they were fundamentally limited. They lacked the internal energy architecture required to build complex, multicellular structures. A single bacterial cell is a rigid, sealed system. It absorbs energy across its membrane, and the surface area of that membrane strictly limits how much energy it can consume. Because of this cruel law of geometry, a bacteria can never grow large enough or complex enough to build a brain, a nervous system, or an appendage capable of manipulating tools. For 2 billion years, life was a flat, unmoving line of microscopic stagnation. Then, exactly once in the entire 4 billion year history of this planet, an impossible accident occurred. One simple cell swallowed another, but instead of digesting it, or instead of the swallowed cell acting as a fatal parasite, the two reached a bizarre, unprecedented biological truce. The swallowed cell became an internal engine, a dedicated biological power plant entirely focused on generating chemical energy. We call these engines mitochondria. This event, known as eukaryogenesis, shattered the energy limits of the single cell. It provided the vast, internal power supply necessary to build complex proteins, to stack cells together, to build specialized organs, and ultimately, to build the human brain. Evolutionary biologists increasingly believe that this specific cellular merger was a statistical miracle. If you were to roll a 1,000,000-sided die, this event is the equivalent of rolling the exact same number, perhaps 10 times in a row. It is entirely possible that there are millions of planets right now, covered in vast, thriving oceans of alien bacteria, that will remain microscopic and simple until their host stars eventually swell and boil their oceans away. They are trapped behind the first great filter. If this is true, humanity is the product of an astronomical lottery win. But biology is only one fraction of the gauntlet. We must step away from the microscope and look back into the terrifying mechanics of astrophysics, because the universe itself actively prevents long-term stability. The cosmos is not a passive theater, it is a hostile, kinetic, firing squad. Let us dissect the mechanics of a gamma-ray burst, one of the most violent and lethal phenomena in the observable universe. When a hypermassive star, perhaps 20 or 30 times the mass of our own Sun, exhausts its nuclear fuel, its core violently collapses under its own immense gravity, as the core crushes inward to form a rapidly spinning black hole. The magnetic fields of the dying star are twisted and pulled into an impossibly tight, chaotic funnel. This magnetic vortex channels the unimaginable kinetic energy of the collapsing star into two perfectly focused, narrow beams of pure radiation, shooting out from the poles of the star at the speed of light. Imagine an incredibly powerful, cosmic sniper rifle. A gamma-ray burst releases more energy in 10 seconds than our Sun will produce in its entire 10 billion-year lifespan. The sheer mathematical scale of this violence is almost impossible to articulate. If one of these beams were to intersect with a planet, even from a distance of several thousand light-years away, the results are instantaneous and apocalyptic. Because the beam travels at the exact speed of light, there is no physical way to detect its approach. The sky would simply flash with a blinding, terrifying light. The high-energy gamma photons would smash into the planet's atmosphere, immediately shattering the chemical bonds of molecular nitrogen and oxygen. These shattered atoms would wildly recombine to form a thick, brown, toxic smog of nitrogen dioxide, entirely blotting out the light of the host star and plunging the planet into a sudden, deep freeze. Simultaneously, the sheer energy of the blast would instantly obliterate the planet's ozone layer, stripping away the only shield protecting the surface from the intense, steady, ultraviolet radiation of its own star. Even after the gamma-ray burst ends, the lethal ultraviolet light would pour down onto the surface, sterilizing the top layers of the oceans. The microscopic phytoplankton, the foundational pillar of the entire global food chain, would be instantly baked and destroyed. The oceans would rot. The biosphere would collapse from the bottom up in a matter of months. Astrophysicists estimate that a lethal gamma-ray burst sweeps through any given region of a galaxy roughly once every few 100 million years. When paleontologists look at the fossil record of Earth, they see the Ordovician-Silurian mass extinction, which occurred roughly 440 million years ago, wiping out 85% of all marine species. Many scientists now point to a random, unpredicted gamma-ray burst as the most mathematically probable trigger for this sudden, brutal culling. We have already been shot at. We simply survived the ricochet. And gamma rays are not the only localized threat. The stars themselves are constantly migrating. Our solar system orbits the center of the Milky Way galaxy, drifting through different galactic neighborhoods over hundreds of millions of years. Sometimes, this drift takes us through dense, active star-forming regions, the cosmic equivalent of walking through a heavily mined war zone. These regions are packed with massive, short-lived stars that inevitably end their lives in catastrophic supernova explosions. A supernova detonating within 30 light-years of a habitable world is a death sentence. The explosion sends a massive shockwave of high-energy cosmic rays accelerating through the interstellar medium. When this wave of charged particles slams into a planet, it triggers a catastrophic mutation rate in biological DNA, while simultaneously stripping away the atmosphere, much like a gamma-ray burst, but over a prolonged, agonizing period. Geologists have drilled into the deep ocean crust of our planet and found concentrated layers of iron-60. This is a highly specific, radioactive isotope that is absolutely not native to Earth. It is forged exclusively in the unimaginably hot, pressurized cores of dying stars. Finding it on our ocean floor means that within the last few million years, an exploding star bathed our planet in the radioactive fallout of its own death. How many promising, intelligent species on other worlds were just beginning to build their first stone tools, or light their first fires, when a neighboring star randomly collapsed and erased their entire evolutionary lineage? In the brutal mechanics of the universe, survival is heavily dependent on pure, blind geographical luck. But what if a civilization survives the biological lottery? What if they happen to exist in a calm, quiet suburb of the galaxy, untouched by supernovas and gamma rays? What if the great filter is not behind us, hidden in our biology or our chaotic neighborhood? The most chilling and mathematically rigorous explanation for the silent sky is that the great filter is an inescapable consequence of intelligence itself. The wall is waiting for us in the future. To understand this, we must strip away the romanticized illusions of human progress and look purely at the cold physics of technological advancement. The history of any intelligent civilization is fundamentally a history of energy extraction. As a society becomes more complex, it requires an exponentially greater amount of energy to maintain its internal structures and fight off the constant, decaying drag of entropy. We began by burning wood, capturing the stored chemical energy of ancient sunlight. We progressed to burning compressed fossil fuels, coal and oil, massively accelerating our ability to do physical work. We split the heavy nucleus of the uranium atom, unleashing the binding energy of the strong nuclear force. A Russian astrophysicist in the mid-20th century proposed a theoretical framework to categorize alien civilizations based precisely on this thermodynamic reality. A civilization in its infancy, much like our own, relies on the dead, chemical remnants found on its home world. A more advanced civilization would eventually need to capture the total, complete energy of its host star, perhaps by constructing vast arrays of solar collectors in orbit. An exponentially more advanced society would eventually harness the entire energetic output of a galaxy. But to climb this thermodynamic ladder, a civilization must unlock the fundamental secrets of physics. You cannot build a global, high-energy society without understanding the deep mechanics of matter, gravity, and atomic structure. And this is where the fatal paradox lies. The exact same physics required to harness infinite, clean energy are the exact same physics required to engineer apocalyptic weapons. You cannot discover how to power a sprawling metropolis with nuclear fusion without simultaneously discovering how to build a hydrogen bomb capable of vaporizing that exact same metropolis. It is a universal, physical constant. The sword and the shield are forged from the exact same mathematics. This creates a terrifying, highly unstable, transitional epoch for any intelligent species. There is a period, perhaps lasting only a few centuries, where a civilization possesses the absolute physical capacity to completely sterilize its own biosphere, but still retains the tribal, aggressive, and deeply flawed neurological instincts that helped its ancestors survive in the wild. We are currently trapped in the dead center of this exact epoch. Humanity possesses thousands of nuclear warheads, sitting in reinforced silos and deep-water submarines, mathematically capable of ending our entire global civilization in roughly 90 minutes. The distance between launching a satellite to explore the stars and launching an intercontinental ballistic missile to annihilate your neighbor is separated only by a shift in software targeting coordinates. If every intelligent species naturally evolves through competition and conflict, as the brutal mechanics of natural selection demand, then it is a statistical probability that a vast majority of civilizations simply failed this test. They reach the atomic age. The pressure of internal conflict or resource scarcity builds to a breaking point, and they press the button. The sky lights up with their own artificial gamma rays, and the planet returns to silence. The radio broadcasts stop entirely. Even if a species miraculously avoids the trap of nuclear sterilization, there are other, more insidious thermodynamic filters waiting for them. The pursuit of endless technological growth on a finite sphere of rock is a physical contradiction. Any energy generated and consumed by a civilization, whether it comes from coal, wind, nuclear fission, or perfectly clean fusion, ultimately degrades into waste heat. It is an unavoidable consequence of the second law of thermodynamics. If a civilization continues to exponentially increase its energy consumption by even a fraction of a percent every year, the sheer volume of waste heat generated by their machines, their server farms, their transportation networks, and their industries will eventually outpace the planet's physical ability to radiate that heat back into the cold vacuum of space. You do not even need greenhouse gases to trigger a catastrophic climate collapse. The sheer thermal output of an exponentially growing, highly advanced civilization will eventually boil their own oceans and cook their own biosphere from the inside out, simply by running the engines of their society. It is the cosmic equivalent of leaving a powerful car engine running inside a tightly sealed, insulated garage. The heat has nowhere to go. When we look up at the night sky and listen to the deafening silence, we are forced to consider the horrifying probability that the window of communicability for any intelligent species is incredibly narrow. Perhaps civilizations do arise frequently. Perhaps they build massive cities, discover radio technology, and begin to broadcast their presence to the stars. But the brutal laws of physics dictate that these same civilizations will rapidly consume their local resources, destabilize their planetary environment, or invent the absolute instruments of their own destruction within a few short centuries. A few centuries of broadcasting is nothing. It is a microscopic flash of light in the vast, deep ocean of cosmic time. If a civilization 1,000 light-years away broadcasted a powerful radio signal for 500 years, but they did so during the time when our own planet was ruled by dinosaurs, that signal washed completely over a deaf, uncomprehending Earth and vanished forever into the deep void. We missed them, and they are long dead. The Great Filter suggests that the universe is essentially a dark, sprawling graveyard, filled with the ruins of thousands of empires that flared into existence for a brief, violent moment, only to be crushed by the inescapable laws of thermodynamics and their own tragic nature. The silence is not a mistake. It is the sound of an entire galaxy trapped behind an invisible, impenetrable barrier. And as our own society grows increasingly complex, as our weapons grow more terrifying, and as our energy demands push our own planet to the breaking point, we are slowly beginning to realize a deeply uncomfortable truth. We have not passed the test. We are merely taking it right now. If we accept the terrifying probability that we are currently navigating the deadliest phase of the Great Filter, we must confront the hidden consequences of our situation. We must look past the immediate threats of nuclear annihilation and ecological collapse, and examine the fundamental architecture of the reality we inhabit. When we truly understand the physical laws governing the cosmos, the silence of the Fermi Paradox ceases to be a mere mystery of missing aliens. It transforms into a profound, existential revelation about the nature of space, time, and our ultimate, inescapable isolation. The laws of physics are not a blank canvas for our technological ambition. They are the heavily fortified walls of a meticulously designed cage. Consider our most celebrated scientific discoveries. When humanity first measured the speed of light, we viewed it simply as a velocity, a mathematical constant to be written in textbooks. We learned that light travels at roughly 186,000 miles per second, and we saw this as a target. We assumed that one day, with enough engineering and enough centuries of progress, we would build engines capable of approaching that absolute speed limit, allowing us to conquer the stars. But from the cold perspective of cosmic thermodynamics, the speed of light is not a target. It is an impenetrable physical quarantine mechanism. To understand why, you must look at the brutal physics of kinetic energy. To accelerate a starship of any meaningful size to even 10% of the speed of light requires an incomprehensible amount of energy. It would require the total combined energy output of our entire global civilization, sustained over decades, just to move a single vessel. But the real horror is not the energy required to accelerate. It is the environment you are accelerating through. Interstellar space is not perfectly empty. It is filled with microscopic grains of dust and rogue hydrogen atoms. If a starship is traveling at 10% of the speed of light, and it strikes a piece of rock the size of a grain of sand, the kinetic energy released by that impact is equivalent to the detonation of a thermonuclear warhead. The ship would be instantly vaporized. The universe is actively hostile to the movement of complex matter. It demands that biology stay exactly where it was born. This is the hidden consequence of our physics. The universe effectively isolates biological outbreaks. It ensures that when a civilization inevitably exhausts its local resources, triggers a runaway climate catastrophe, or invents the ultimate weapon, the resulting tragedy is strictly localized. The destruction is contained to a single, microscopic solar system. The sickness cannot spread. The silence of the Milky Way is maintained by the sheer, insurmountable friction of distance. We are not explorers standing on the shore of a new world. We are inmates pacing the floor of a locked cell, dreaming of an ocean we can never touch. This realization violently shatters our most fundamental understanding of time and human destiny. We are deeply conditioned by our brief evolutionary history to view time as an infinite upward trajectory. We automatically assume that thousands or millions of years from now, our distant descendants will be walking on the exoplanets orbiting Alpha Centauri, harnessing the power of black holes and weaving a sprawling, magnificent galactic empire. But if the Great Filter is a thermodynamic inevitability, and the speed of light is an absolute quarantine, then our concept of a long-term future is an evolutionary hallucination. We are not the ancient, pioneering ancestors of a future cosmic civilization. We are the terminal generation of a highly improbable biological experiment, playing out our final, desperate acts in total isolation. Every monument we have ever built, every sprawling city we have illuminated, every piece of data stored in our massive global servers, and every profound truth we have discovered in our particle accelerators. All of it is being recorded on a fragile, temporary ledger. We are archiving our history inside a sealed vault that will eventually be swallowed by the expanding red giant of our own sun. The universe is a closed system that absolutely refuses to preserve information. Entropy is the ultimate, undefeated eraser. Everything we are, and everything we will ever do, is mathematically guaranteed to be dismantled and forgotten by the uncaring laws of thermodynamics. But even if we miraculously defy these odds, even if humanity somehow survives its technological adolescence, solves the thermodynamic trap of its own biology, and figures out how to survive in the freezing, irradiated deserts of deep space, we are facing an even more terrifying consequence on a macroscopic scale. We are in a relentless, losing race against the physical fabric of reality itself. In the late 1990s, astronomers who were observing distant, exploding stars made a discovery so deeply unnerving that it completely broke our standard cosmological models. Since the discovery of the Big Bang, we knew that the universe was expanding. We assumed that the gravitational pull of all the galaxies pulling against one another would gradually slow this expansion down over deep time. But the supernovas told a different, horrifying story. They revealed that the universe is not slowing down. The expansion is actively accelerating. Astrophysicists attribute this phenomenon to a mysterious, invisible force they call dark energy. It is an unknown pressure that permeates all of reality, making up nearly 70% of the total energy in the universe. Dark energy is not simply pushing objects away from one another. It is fundamentally creating new space. The physical nothingness of the cosmic void is multiplying, stretching out in all directions, and dragging the galaxies with it. The further away a galaxy is from us, the faster the space between us is expanding. Because this expansion is accelerating exponentially, it is creating a terrifying, invisible boundary in the deep cosmos known as the cosmic event horizon. Right now, as you sit here and process these words, there are thousands of distant galaxies crossing that invisible threshold. The raw physical space between us and those galaxies is now expanding faster than the speed of light itself. This does not violate the laws of physics, because the galaxies are not moving through space faster than light. The space itself is simply inflating, but the consequence for any observer is absolute and permanent. The light emitting from those distant stars, traveling at its maximum universal speed, is like a runner trying to run backwards on a treadmill that is infinitely accelerating. That light can never, ever reach our telescopes. It is physically impossible. Those galaxies, and any potential civilizations living within them, have been permanently severed from our observable reality. Every single second of every single day, the observable universe gets slightly darker and slightly emptier. Entire galactic clusters, filled with billions of suns and perhaps billions of silent, dead worlds, are quietly slipping over the edge of reality, erased from our sky forever without a sound. Project this accelerating, brutal expansion into the deep future. Astrophysicists calculate that in roughly 2 trillion years, the night sky of Earth, or whatever dead rock remains in its place, will be almost entirely pitch black. Every other galaxy outside of our immediate local cluster will have been pushed so incredibly far away and so unimaginably fast that their light will have completely faded into the infrared. then into faint radio waves, and then out of existence entirely. The universe will appear completely empty. If by some impossible miracle, a new intelligent species evolves in that distant, future era, and looks up at the night sky, they will have absolutely no physical evidence that the universe was ever larger than their own isolated galaxy. They will not be able to detect the cosmic microwave background. They will have no physical evidence of the Big Bang. They will have no evidence of an expanding cosmos. Their most brilliant scientists, using their most advanced instruments, will conclude with absolute, verifiable certainty that they are entirely alone in a static, dark, and infinitely empty void. The universe is actively working to erase the evidence of its own violent creation. This is the most haunting, hidden consequence of all. We are currently living in a temporary, highly privileged window of cosmic time. We exist in a brief, fleeting era where the evidence of the universe is still partially visible to us. We can still see the distant galaxies scattered across the dark. We can still measure the ancient afterglow of the Big Bang. We possess the unique, agonizing ability to comprehend the true, terrifying scale of reality, precisely at the exact historical moment when we are paralyzed by our inability to reach it. We look out into the deep void, desperately seeking a reflection of our own intelligence. We want to find a neighboring empire, a signal in the noise, a confirmation that we are part of a grander cosmic community. But the mathematics and the physics are explicitly clear. We are standing on the shore of a vast, freezing ocean, screaming into the dark, knowing not only that no one is coming to save us, but that the ocean itself is rapidly boiling away into nothingness. The great tragedy is not that the universe is cruel. Cruelty implies intent. The tragedy is that the universe is a blind, unthinking machine, running perfectly on a set of thermodynamic laws that simply do not factor in our existence, our survival, or our desire for companionship. The filter is real, the walls are closing in, and the cosmic clock is ticking down to an era of absolute, unbroken darkness. The true terror of the Fermi Paradox is not merely that we are alone. The terror is that our isolation is mathematically mandated. The silence we hear from the depths of space is not an empty channel waiting to be tuned. It is a profound, physical answer. It is the sound of the great filter operating perfectly, exactly as the cold, uncaring laws of thermodynamics demand. The cosmos is a machine built to run down, to slowly dismantle complexity and return everything to a state of absolute, unmoving equilibrium. Life, and especially intelligence, is a glaring, temporary violation of that order. It is a microscopic rebellion that the universe relentlessly seeks to crush. We have spent centuries building massive, delicate eyes and ears to pierce the veil of the night, driven by a deeply ingrained biological need to find our place in a grand design. But the ultimate irony of our advancing intelligence is that it has merely allowed us to accurately measure our own doom. Our telescopes and our equations have systematically stripped away every comforting illusion our ancestors held dear, leaving us with a brutal, terrifying clarity. When you step outside tonight and look up at the stars, do not see a canvas of infinite, inviting possibilities. See a vast, ancient graveyard. See the dead light of distant suns that have already sterilized millions of promising worlds with random, invisible bursts of radiation. Understand that the freezing, impossible darkness between those stars is not a frontier waiting to be conquered. It is a mathematically perfect quarantine zone, designed to ensure that when a civilization inevitably collapses under the weight of its own technological arrogance, the tragedy is permanently contained. Humanity is an astronomical anomaly. We are a fleeting, highly unstable, biological mutation clinging to the thin crust of a fragile rock, orbiting an entirely unremarkable star. We are wandering blindly through a cosmic minefield, completely isolated from any external guidance or warning. The universe did not design us, it does not need us, and when our brief window of existence finally closes, the universe will absolutely not remember us. We are currently standing at the most dangerous precipice in the history of our species, gripping the technological instruments of our own absolute destruction. We are playing a desperate, high-stakes game of survival against the fundamental, unyielding laws of physics, and the historical record of the galaxy, written in the deafening silence of the radio spectrum, strongly suggests that the house always wins. Every towering city we build, every digital archive we fill, and every profound truth we pry from the fabric of reality is nothing more than a desperate, temporary whisper against the relentless march of entropy. We are a brief spark of consciousness in an environment that overwhelmingly demands cold, dead matter. There is no grand, galactic community waiting to elevate us. There is no ancient, benevolent empire traveling across the void to save us from our own fatal flaws. We are alone. We have always been alone. And the inescapable mathematics of reality dictate that we will die alone. The sky is dark, the filter is real, and the silence is the only truth we will ever receive.